welcome back to my channel. Today we're going to be talking about GCF. So what does GCF stands for? So the G stands for greatest, common, and the C stands for common, and the F stands for factor. So what this means is we're trying to find the highest, so this basically means the highest common, so common basically means the same factor of two numbers. And if you don't know what factors are, there is a link to that in the icons above right here. So if you're wanting to know what factors and multiples are, just check out that video. Okay, so when you're working with GCF, you're trying to find the greatest common factor between two or more numbers. For example, if we have a question like I've set up here, find the GCF of 12 and 18. So we're trying to find the greatest common factor between 12 and 18. Well, how would we do this? Again, you can watch the video on factors and multiples to understand what factors are. So we would list out the factors of 12 first of all, and I know the factors of 12 are 1, 2, 3, 4, 6, and 12. And then I would list the factors of 18. So I know the factors of 18 are 1, 2, 3, 6, 9, and 18. So I know those are the factors of 18. Now it says common factors. So we're going to try to find the numbers that are in common. So 1 is in common, but 1 is a factor of every single number, so that doesn't really count. We have 2 in common. We have 3 in common. We have 6 in common. And no other numbers are in common. So these are our common factors. And now if we look at the box here, it says we're trying to find the highest, the greatest common factor. So now we're just going to list them out. So we have 2, we have 3, and we have 6. So we know that 6 is greater than the rest of these numbers. So since it says highest common factor, our answer is going to be 6. So the GCF of 12 and 18 is 6. Okay, so now we know what to do if we're trying to find the GCF of two small numbers. But what happens if we're trying to find the GCF of two really big numbers like 52 and 36? I mean, we could know the factors of 36, but what about 52? It's not like everyone just memorizes the factors of 52, right? So what you can do if you to find the greatest common factor, and this is one of the easiest ways to find the greatest common factors of any number. So what you can do is we can use a prime tree. And a prime tree is set up basically like this. So we're going to take 52. So we basically just write down 52 right here. Then we just draw two lines and we divide 52 by two numbers. And you can divide it by any two numbers. I'm going to divide 52 by 2. And if we divide 52 by 2, we're going to get an answer of 26. And you write 26 in the other one. And also, if you don't know what prime numbers are, you can still go back to the factors and multiples video and check out what prime numbers are. So now what we're going to do is we're going to circle the prime number. So 2 is a prime number, but 26 is not a prime number, so we're going to keep on dividing 26. And if we divide 26, and I'm going to divide 26 by 2 again, if we divide 26 by 2, we're going to get an answer of 13. And we see that 2 is a prime number, and 13 is also a prime number. So that means we're done. When we don't have any more numbers to divide and we end up with 2 prime numbers, that means that we're done. And this is called using a prime tree. Now what we're going to do is we're going to write all of these numbers out. So we have 2, 2, and 13. And this would be the prime factorization of 52. And the reason why it would be the prime factorization of 52 is if we multiply these numbers, and I'm just going to multiply them right here. So 2 times 2 is 4, and then we're going to do 4 times 13. So we're going to do 13 times 4, and we get 52. So if we multiply all these numbers, they equal 52, and they are prime. So that's why we call it prime factorization, because we're using prime numbers, and these are the factors of 52. So now that we know the factors of 52, we're going to do the same thing using a prime tree with 36. So I'm just going to draw a really big line here. And now we're going to work out 36. So we're going to write down 36 again. So I'm going to write it right here. So 36, split it into 2, and I'm going to divide it by 4 this time. 4 and 9. And we split those further because neither of these are prime, and you can divide them further. And we get 2, 2, and 3, and 3. And we end up with these prime numbers, and since we know that these are prime, we're going to just circle them, and there's no more numbers left to simplify. So the prime factorization of 36, I'm going to write the prime factorization of 36 right here. So 36 prime factorization would be 2 times 2 times 3 times 3, right? And now if we do multiply these together, so 2 times 2 would be 4, and 3 times 3 would be 9, and 4 times 9 would be 36. So we know that we're right. So now that we're done with the prime factorization of both the numbers, now what we're going to do is we're going to do the last and final step, where we'll get the answer of the GCF. So now we know the prime factorization of both numbers, and I've just written them down here so we know what they are. So now the last step to find the answer is now we are going to find the common numbers between both of the prime factorizations. So what I mean by that is we look at the bottom, there's 1, 2 here and 1, 2 here. So these two are common. 1, 2 here and 1, 2 here. These two are common. And there isn't any 3 here and another 3 here. So basically, we're trying to find the factors that are the same top and bottom, and we're circling that and making it a pair. So we have 1 3 at the bottom, but we don't have any 3s at the top. There's only a 13. And we only have a 13 at the top, and we don't have any 13s at the bottom. So we can't make a pair of the same numbers. We can make a pair for these numbers because they're the same. We can make one pair because there's 1 2 and another 2. 2 here and 1 2 here. So we can make groups and make them pairs. But we can't do it with these numbers because there isn't the same number on the other side. There needs to be the same number on each side. So now we would take the numbers that are pairs and we would make them into one number. So these 2's would come and make 1 2, and these 2's would come and make 1 2. Okay? And now what we would do is we would multiply these two numbers, and then 2 times 2 would be 4, and 4 would be the greatest common factor, and this would be your answer. Okay, so now let's work on another question. So this question says, find the GCF of 84 and 27. So you can work on this if you want to, and I recommend you to, but I'm going to work on this and come back with you really quickly with the prime factorization of 84 and 27. So now, regardless of what answer you got or what prime factorization you got, this is what I worked out. So I worked out the prime tree, and I got 84. I got the prime factorization of 3, 7, 2, and 2, and for 27, I got 3 times 3 times 3. So now we're going to try to find the ones that are in common. And the ones that are in common, so now we have 3's in common, and no other number is in common. So this 3 is the only one that we have. And we're going to bring this number down, and we're going to make it 1. And since there's no other number that we can multiply the 3 with, the 3 would be our answer. So our answer would be 3. Thank you guys so much for watching. Make sure to like and subscribe to my channel and comment down below any questions you have or any videos you guys want to see next. And I'll see you guys all next time. Bye!